Hi everyone. In this video, we are going to see whether 1.33333333, this number, right, with a repeating decimal digit 3, we are going to see if it is a rational number or irrational number. So let me first write down the number. So our number is 1.333. This is a repeating decimal digit and it goes on and on forever. So it goes infinite times, right? So I'm going to put like 3 dots here. So that indicates that the repeating decimal digit 3 would appear infinite times, right? And we have a number like that. Now we are trying to figure out whether this number is a rational number or irrational number. Well, if we can somehow express this number in form of the ratio of two co-prime numbers, we can say that it is a rational number. Now, if you are not able to express it in terms of a ratio, then obviously it will be an irrational number, right? So now let's see if we can do something about it. Suppose this number is x, right? I'm going to say, okay, let's assume that this is x. Let's say this is x. So our number is x and x is equal to 1.333333. The decimal digit repeats infinite times, right? Now, if we multiply x by 10, then let's see what happens. So suppose we are now multiplying both sides, right? So on the left side, we have 10 times x. So we are multiplying by 10. So 10 times x will become, the decimal digit will shift to the right by one position. So this will become 13.33333 again this 33333, it will continue infinite times. This repeating decimal digit will appear infinite times. Now what we are going to do, let's try to subtract the x from 10x. So now we are going to subtract x. That means, let me write down the value of x first. So our x was 1.333333 like that. So our x is kind of like that, and we are going to do a subtraction right here. So we are going to subtract x from 10x, and let's see what happens with that subtraction, right? So we are going to subtract it, and when we subtract, we get, so we are going to do a subtraction here. So this is a subtraction, we are going to subtract it, and then the value that we'll get on the left hand side, it will be 9x is equal to, on the right hand side, let's see what happens. You see, the very interesting thing here is that the infinite number of 3's after the decimal point, it's actually same for both of them, right? That means when you do the subtraction, this portion, the decimal portion, will actually cancel each other. The decimal portion will cancel each other, and we will be left with 13 minus 1, which is 12. So we'll be left with just 12 without any decimal portion, because the decimal portion will cancel out each other when you do the subtraction. So now we see that, okay, 9x is equal to 12, and from here can we say that x is equal to 12 divided by 9, and we can probably simplify that little bit. So we have 3 as a common factor, so that becomes 4 divided by 3. Alright, so now we see that we have been able to express our original number in form of a ratio, and in form of a ratio of two co-prime numbers, which are 4 and 3. So this is now, the ratio is 4 divided by 3. That's the ratio, right? So because we are able to express it in terms of ratio or in form of a ratio, we are sure that it is a rational number. It is not an irrational number. So we can say that our original number is a rational number. So I'm going to quickly write it there. So our original number, which is right here, that is a rational number, because we have been able to express it in form of a ratio of two co-prime numbers. So that's a rational number. Now to verify our result, let's do a simple division and see what happens. So now we are going to do a plain division. Now let's do a plain division on the side. Let's divide 4 by 3 and see what happens. So we're going to divide 4 by 3. So 3 goes 1 times, that would be 3. Then we are left with 1. We put a decimal point, we get a 0. Then again 3 goes 3 times, that is 9. Then again we have 1 remainder, then we get a 0. Again 3 goes 3 times, again 9. Then again we get a 1. We can get a 0 here because you have the decimal point already. Again 3 goes 3 times. You see, there is a pattern developing here. It's the same pattern, that this division will never end, and we will get a whole bunch of 3's or decimal digit 3 in our quotient, right? So this pattern will continue forever. This division will never end. That means the way we represented our original number as 4 divided by 3, that is actually accurate, because when you do the division, we again get to see our original number coming up as a quotient for this division, right? So that means that our original number is actually a rational number and not an irrational number. I hope it made sense. Thank you for watching. See you in the next video.